Now we're going to look at how we can use Venn diagrams to draw out certain statements into a picture. And then we can use those pictures to actually analyze logical arguments. So a qualified proposition is defined as a statement that asserts a relationship between two sets. Qualified propositions often use the words or phrases all, if, then, none, or some. And what I want to do is look at how those phrases or words relate to the relationship between the two sets. Let's start with all and if then. All and if then mean that all of the elements of one set are contained within another set that's described in the sentence. If we have, for instance, the sentence all cats are mammals, that would mean that the set of cats is entirely contained within the set of mammals. It's entirely contained because all cats are mammals. So when I can draw that out by putting the set of cats drawn within the set of mammals. Now, because all cats are mammals, if you're inside the cat circle, you're automatically a mammal. However, the opposite is not true. If you're inside the mammal set, you may be a cat if you're inside the cat circle as well. But if you happen to be inside the mammal circle but outside of the cat circle, then you're a mammal but not a cat. So not all mammals are cats. So the order of the two nouns matters when we use the word all. So all cats are mammals means that the cat circle or cat set is contained within the mammal set. We can look at if-then in the same way. And in fact, if you recall correctly from our logic rules, all if-then statements can be written as all statements, and all statements can be written as if-then statements. If she is a doctor, then she knows CPR. This would represent a set of doctors being a subset of the set of people who know CPR. If you are a doctor, you must know CPR. That's what the if-then is saying. Now, if you know CPR, you may be a doctor, but you may also be someone that is inside the no CPR circle, but not inside the doctor circle, as you can see from this green asterisk. So remember, if-thens cannot automatically be reversed. So when you see an if-then statement, what you're dealing with is the if subject being a set that is entirely contained within the then subject. So one thing to kind of be aware of here is when you look at all and if-then statements, when we say all, that represents an inside set with the noun that's described right after the all, and then that relates to the outside set, which is the object that we see in the remainder of the sentence. So all inside set are outside set. Okay, and the same thing with if-then. If represents the inside set, and then represents the outside set. So any all statement or if-then statement can be written with one set inside the other set to kind of understand how these two nouns or objects relate to each other. Some and none rather are drawn differently. Some, when you have a sentence with that word in it, means you have an overlap between two sets, because it's not saying that all of something is within something, it's saying some of it. So for instance, in the example I have here, some flying animals are birds, we would show that because it says some, we have an overlap between the two sets. Flying animals overlaps with birds. So whenever you see the word some in a sentence, that means you have two sets that are overlapping. The word none or no means the two sets do not overlap at all. So our final example on this slide, no reptiles or mammals, that means that these two sets are totally distinct. Reptiles is a separate set entirely from mammals. We don't have any overlap between reptiles and mammals. So they are two distinct sets in our Venn diagrams. Next, let's use these pictures to analyze arguments. We can draw the premises of an argument into a Venn diagram and then determine if the conclusion makes sense with that diagram. If the conclusion is guaranteed by the premises. So if the conclusion must follow based on the picture that you have of the premises, the argument is said to be valid. So a valid argument is one in which the premises guarantee the conclusion. So let's look at a couple of examples of this. Argument 1 here. We have the first premise, all cats are mammals. Now remember on the last slide, we had drawn that out. Cats is a set inside of the mammal set. The next premise is a little bit different because it's talking about a single individual. My pet Vic is a mammal. So Vic is an object that would go into this picture. So let's think about where Vic might be. If Vic is an animal, Vic has to be within the mammal circle. Now, you initially might just think, well, that's the circle where we have mammals. But remember, a cat is a mammal too, and the mammals include everything within this mammal set, including the cat circle. So Vic could be inside the mammal set but outside of the cat set, or Vic could be inside the mammal set and inside the cat set. So Vic could be in these two places. Okay, so of those two places, the only place Vic could not be is Vic cannot be outside of the mammal set, because if you're outside of the mammal set, you're not a mammal. So I cannot put Vic outside there. So I've actually drawn the two premises. I've drawn all cats are mammals, and I've drawn where Vic could be in that diagram. Now what I'm going to do is I'm going to look at the conclusion and see if it follows. So the conclusion says that Vic is a cat. Well, does that have to follow from the picture? Well, Vic could be a cat, but Vic may also not be a cat. Vic could be in either of those two places based on the picture I have of the premises. Because Vic could or might not be a cat, we can't draw this conclusion for sure. It is not guaranteed by the picture. So therefore, this is not a valid argument. So even though Vic could be a cat, in logic, we say this is not a valid argument because it is not absolutely guaranteed. If there's a possibility that Vic might not be a cat, you have to say it's not valid. So to be a valid argument, the conclusion must absolutely follow. Let's look at one more example. In argument 2, we have the same first premise. We have the premise that all cats are mammals. So I'll draw that out first. And now we have a second premise that is different. My pet Henry is not a mammal. Well, to not be a mammal, you would be in, or you would actually be not in the mammal set. So that means you'd have to be outside of the mammal set. So you'd be somewhere out here outside of the mammal circle. Do my best here to draw that in. So if Henry is out there, let me just draw Henry's name in that region. Oops. There's Henry. Henry has to be outside. Now let's analyze the conclusion based on that picture. So you always draw just the two premises and then we analyze the conclusion. The conclusion is Henry is not a cat. Well, think about where Henry is. Henry is definitely outside the cat circle. Henry is not inside the cat circle, so that is a valid conclusion. So this is a valid argument based on the picture because Henry is outside of the cat circle, so Henry cannot be a cat. Here's a third example using an if-then statement. Here we have the premise, if she is a doctor, then she knows CPR. Remember, if-then statements are just like all statements. The if statement is going to be entirely within the then statement. So if she is a doctor, so doctors are entirely within the then part, which is knows CPR. Okay. Now my second premise is that Jamila is not a doctor. So let's think about where that would be. Okay, if Jamila is not a doctor, so think about where not doctors are. If you're not a doctor, you can't be in the doctor circle, which means you would have to be outside of the doctor circle. So anywhere outside of the doctor circle. I'm trying to shade that here. So you'd be anywhere outside of the doctor circle. So if we think about the locations for someone who is outside of the doctor circle, which is what Jamila is, Jamila would have to be within either outside of the doctor circle, but within the CPR circle. So Jamila could be here. But Jamila could also be outside of the doctor circle and outside of the CPR circle. So Jamila could also be here. So when we now look at the conclusion, Jamila does not know CPR, we aren't guaranteed that. It could be that Jamila does not know CPR because Jamila could be outside the CPR circle, but it could be that Jamila knows CPR but is not a doctor. We can't be sure. Jamila could be in either of these, could be in the set of CPR or not be in the set of CPR. Because we don't know for sure, this conclusion is not guaranteed. And therefore, this argument is not a valid argument. Now, one thing I should say about an argument that is not valid is that we kind of come full circle on where we started in chapter 1, which was actually at the end, with fallacies. If you recall correctly, a fallacy is an argument in which the conclusion is not well supported. So that's in fact exactly what is happening when you have an argument that is not valid. When you have an argument that's not valid, you have a conclusion that is not supported by the premises. So this takes us full circle to where we started in the